Earth, the third planet from the Sun, is the only planet known to support an atmosphere with free oxygen, oceans of liquid water, and living organisms. This video will help you to have a better understanding of the Earth's layers, spheres, and plate tectonics. The Earth is made up of many layers due to planetary differentiation, during which denser materials sink to the center and lighter materials rise to the surface. The four concentric layers of Earth are inner core, outer core, mantle, and crust. The crust is the outermost rigid layer of Earth, which ranges in depth from approximately 5 to 70 kilometers. It is like the skin of an apple, so thin that it only makes up 1% of the entire volume of the planet. There are two types of crust, continental and oceanic crust. While the continental crust consists of sodium, potassium, aluminum, and silicate rocks like granite, oceanic crust is more dense and is composed of magnesium and silicate igneous rocks like basalt. The mantle is the widest section of the planet, having an average thickness of 2,886 kilometers and making up 84% of Earth's volume. It is composed mainly of silicate rocky materials. The upper mantle is just beneath the crust, and together they are known as the lithosphere. Unlike lithosphere, which is the coolest and most rigid of all layers, asthenosphere, which lies beneath lithosphere, contains weaker plastic rocks which flow slowly due to heat and pressure. The very slow motion of lithospheric plates floating on asthenosphere is responsible for tectonic activities, which are associated with earthquakes, continental drift, and formation of mountains and volcanoes. This process will be explained further later on in this video. The lower mantle is 2,243 kilometers thick and composed of olivine, magnesium, and iron. It is mostly solid due to the fact that the pressure in the lower mantle is a maximum of 1.3 million times that of the surface. The structure of it is quite controversial, as some geologists believe subducted slabs of lithosphere settle there, while others suggest it is entirely unmoving and does not even transfer heat by convection. The outer core is 2,300 kilometers thick, composing of 80% iron and 20% of other lighter elements such as nickel. Although it has a composition similar to that of the inner core, it is in a low viscosity fluid state because it is not under enough pressure to be solid. It has a much higher density compared to the mantle and crust, and its temperature is up to 4,030 Celsius. The motion of the outer core flowing around the inner core produces the magnetic field of the planet. The inner core is the hottest part of the Earth with temperature as high as 5,400 Celsius. It is also composed mainly of iron and nickel, but it also consists of many heavy elements including gold, platinum, silver, and palladium. Due to the extreme high pressure present at the center of the Earth, the melting temperature of the elements dramatically increases, enabling it to be solid. Geologists also suggest that the inner core is rotating slightly faster than the rest of the planet, which may help to explain why Earth's magnetic field reverses polarity. All of the processes on Earth are driven by the four interconnected spheres of Earth, which are lithosphere, hydrosphere, biosphere, and atmosphere. Lithosphere refers to the rigid, rocky crust covering the entire planet. It includes the Earth's crust and uppermost part of the mantle. Examples include mountains, rocks, and soil. Hydrosphere consists of all water on Earth, both in solid and liquid state. Examples include oceans, rivers, glaciers, and rain. Biosphere is composed of all the living organisms on Earth. Examples include one-celled organisms, plants, humans, and animals. Atmosphere is the layer of gases surrounding the Earth. It consists of a mixture of gases composed of nitrogen, oxygen, and carbon dioxide. Water vapor and wind are examples of atmosphere. Often, multiple spheres can occupy and interact within the same space. In this picture, for example, trees in the forest draw water and nutrients from the soil. The deers and birds breathe in oxygen and releases carbon dioxide into the air. The interactions between the four spheres are essential to life on Earth. According to the theory of plate tectonics, lithosphere is divided into 7 major and many minor plates which float and move on the top of the mantle. This movement is driven by convection currents, and the locations where two tectonic plates interact are known as plate boundaries. The 3 types of boundaries are divergent, convergent, and transform boundaries. At divergent boundaries, 2 plates move apart from each other, and the newly created space in between is filled with new crustal material sourced from the molten magma that forms below. The divergence of 2 oceanic plates contribute to seafloor spreading and the formation of an underwater mountain range known as mid-ocean range. One famous example is the Mid-Atlantic Range. When 2 continental plates diverge, a valley-like rift develops. Initially, as the crust widens, valleys form, rivers flow through them. Eventually, the crust widens to the point that a piece of continent breaks off. Water from the ocean will rush in, forming a new water basin. The African Rift Valley is a good example. Convergent boundary, also known as destructive plate boundary, is an actively deforming region where 2 plates come together. There are 3 subtypes of convergent boundaries: continental-continental, oceanic-continental, and oceanic-oceanic convergence. When both of the plates are continental crust, a collision zone is created. Continental rocks crash into each other and deform to create couple mountain ranges. The Himalayas, which resulted from the collision of the Indian and Eurasia plates, is a famous example. When an oceanic crust meets a continental crust, a subduction zone is created. The denser and thinner oceanic plates descend beneath the lighter and thicker continental plate. As the oceanic crust sinks, a deeper oceanic trench or valley is formed at the edge of the continent. Being pulled deeper and deeper into the earth, the base of crust melt and become magma due to high pressure and temperature. The magma collects in magma chambers and eventually forces its way to the surface through a vent in the crust. Thus, a volcano is created on the overriding plate. A subduction zone is also created when 2 oceanic plates move towards each other and the older plate is forced under the younger one. This process leads to the formation of chains of volcanic islands known as island arcs. A transform plate boundary is formed when 2 plates slide past each other. Often, a linear fault valley or undersea canyon is created as the plates grind along. Unlike the 2 other types of boundaries, no magma is formed and no crust is being created or destroyed during the process. Volcanoes are associated with 3 types of tectonic structures: hotspots, divergent, and convergent boundaries. We already talked about how the latter 2 make volcanoes, so only hotspots will be introduced in this section. Hotspots are places within the mantle where rocks melt to generate magma and the magma rises, reaching the surface. A hotspot is quite stationary, so when the plate continues to move over it, older volcanoes formed by the hotspots before move away, while newer ones form over the top of the hotspot. Such lines of a volcano is known as hotspot tracts, and the most famous example is the Hawaiian Islands. Earthquakes is the shaking and vibration of the Earth's crust. Since the movement of tectonic plates are not a smooth process, pressures and tensions tend to build up inside the crust. When the tension is eventually released, earthquakes happen. All 3 types of plate boundaries produce earthquakes. At both transform and divergent boundaries, earthquakes are shallow, running as deep as 25 kilometers and tend to have magnitude smaller than 8.5. At convergent boundaries, earthquakes are found in several settings ranging from the very near surface to several hundred kilometer depths. Earth's largest earthquakes often happen along convergent boundaries. Some of them in Alaska and Chile exceeded magnitude 9. And that concludes this video. Thank you for watching.